Hello, my little mathematicians. Today we're going to review all the operations of adding, subtracting, multiplying, and dividing with fractions. So in your textbooks, page 101, or this page in your packet. If this were an assignment, we would not do what I am doing of trying to cram my work in the margins. We would show our work neatly on a separate sheet of paper. However, this is not being turned in for credit. This is just a warm-up, so it's fine if you show your work directly on here. Okay, when I'm multiplying, I do not need to get a common denominator. I can just jump straight into seeing if anything can cross cancel. No for the 3 and 5, yes for the 4s. Both of those can cross cancel and become 1 because 4 can go into both, and 4 divided by 4 is 1, and same here, 4 divided by 4 is 1. Now I'm left with 1 and 3 on top, so when you multiply those, 1 times 3 is 3, and on the bottom you have 5 times 1, which is 5, and you can't reduce that, so you're done. Okay, my next one says 5/7 times 9/10. Well, these can't cross cancel, but 5 can go into both of these. 5 divided by 5 is 1, and 10 divided by 5 is 2. Now I'm left with 1 times 9 on top, which is 9. 7 times 2, which is 14 on the bottom. That can't reduce, so I'm done. Okay, remember, you're always welcome to try any of these on your own first and then just check back in with us. Okay, so for number 3, we're adding, and when I add, I want to rewrite it vertically, one on top of the other. So let's do 2.5 over 3/8, and I'm adding these. The reason I do this is because when I'm adding or subtracting, I need to get a common denominator, which in this case, both 2 and 8 can become 8. So you think to yourself, what did you multiply the 8 by to become 8? 1, so 3 times 1 is 3. 2 times what is 8? 4, so do the same thing on top. 1 times 4 is 4. Now that I have common denominators, and I just rewrote this, 4/8 is equivalent to 1/2. It's the same thing. 3/8 is equivalent to 3/8. Now I just combine the numerators. 4 plus 3 is 7, and keep the denominator the same of 8. Don't forget that whole number. 2 plus 0 is 2. You can't reduce 7/8. It's already proper, so I'm done. 2 and 7/8 is my final answer for number 3. Okay, number 4, I'm subtracting. Now when I was adding, it wouldn't matter if I put 2.5 over 3/8 or 3/8 over 2.5, but when you're subtracting, the bigger number needs to go on top. Okay, and if it's written like this, it's easy because it tells you the correct order. It's this minus this. So whatever comes first goes on top, 1 3/5 minus 5/6. What can 5 and 6 both become? Think to yourself. And hopefully you said they both can become 30. Okay, well, what did you multiply the 6 by to get 30? You multiplied it by 5. So 5 times 5 is 25. What did you multiply the 5 by to become 30? 6. So 3 times 6 is 18. Now, can you take 25 away from 18? No, you can't. So what I need to do is I need to borrow from the whole number, and then I'm going to add 1 to 18 over 30, but I'm going to add it as a fraction. And now you can see why I like to not cram things in here. In fact, let's rewrite this. Right now I have 18/30 minus 25 over 30. Okay, and when I went to borrow from the whole number, I'm going to add 1 as a fraction, and I'm going to add the fraction as the same number over itself. What number should I choose to be over itself? Whatever this denominator is. Okay, because again, when you add 1, you can add it as any number over itself that you want. Why not pick this denominator so that when you go to combine them, you just keep the denominator the same and combine your numerators. Now you have a big enough numerator to take 25 away from. Okay, so 48 minus 25 you get 23. So you have 23 over 30. You can't reduce it, so you're done. Okay, my next one is dividing. When you divide, you keep the first one the same. If they were mixed numbers, you'd first have to change them to improper. So you have an improper divided by an improper. Same thing with dividing. Okay, now these are already just normal fractions. So I keep the first one the same. Change division to multiplication and flip that second fraction. You only do keep, change, flip when you are talking about dividing. Okay, 3 can go into both of these. So 9 divided by 3 is 3, and 3 divided by 3 is 1. When you go to multiply across, on top, 1 times 3 is 3, and 1 times 7 is 7. So you have 3/7 for that answer. And now you can see why we say don't cram it in the margins. It just gets really messy and hard to read. And then you make simple errors that you otherwise wouldn't have made. Okay, so for this one, it's already a single fraction divided by a single fraction. So keep the first one the same. Change division to multiplication and flip that second fraction. Keep, change, flip. Okay, now multiply across. 1 times 8 is 8. 3 times 5 is 15. You can't reduce that, so you're done. Number 6, you should have gotten 8/15. Okay, number 7. Lucy cuts a board that is 3/4 yards long into pieces that are 3/8 yards long. How many pieces does she cut? So you're probably debating between dividing or subtracting. Which one do you think it is? Well, when you're trying to figure out how many pieces can fit inside of something, like you have this amount, this is how much you have, and you're trying to divide it up into pieces that are each this much. Okay, so it's how much you have divided by how much you're trying to do each piece. And sometimes this number is bigger because what if you have like a fractional amount of a bar, you're on a stranded island and there's 8 of you and you have to split up that fractional amount of a bar among all 8 of you. Okay, so it's not always the bigger number divided by the smaller number. Okay, keep that in mind. It's how much you have divided by how many people or how many pieces are you trying to break it up into. Okay, now that I have it set up, we're going to keep the first one the same, change division to multiplication, and flip that second fraction. Okay, these can cross cancel by what you say? Hopefully you said 4. If you did 2, then you just had to do it twice. 8 divided by 4 is 2, and 4 divided by 4 is 1. What can go into both of these? 3. 3 divided by 3 is 1, and that 3 divided by 3 is 1. When you multiply across, you have 1 times 2, which is 2, and 1 times 1, which is 1, which means how many pieces does she cut? She cuts 2 pieces. Now, some of you guys don't like to cross cancel. You just reduce at the end. That's fine. As long as you fully reduce it down to 2 pieces, that's fine. All right, for our next one, it says divide mixed numbers. So like I said earlier, I could just jump straight into the keep, change, flip because this was already a single fraction divided by a single fraction. But when you have a mixed one, you first have to change it to an improper. Same thing if you were dividing. You would change mixed numbers to impropers for multiplying, as well. Okay, so now we have a denominator of 3. And to get my numerator, you go 3 times 3 is 9 plus 1 is 10. Okay, and then this is already a fraction. So keep the first one the same, change division to multiplication, and flip that second fraction. Do you see anything that can cross cancel? What can go into 10 and 2? 2 can. 2 divided by 2 is 1. 10 divided by 2 is 5. What can go into 3 and 3? 3 can. 3 divided by 3 is 1, and that 3 divided by 3 is 1. So when you multiply across, you get 5 times 1 is 5. Oops, it's up here. And 1 times 1 is 1. And 5 over 1 is just 5. Okay, let's go ahead and try the next one. Running out of space here, so let's just write it directly on here. So that stays a 4. 4 times 4 is 16 plus 1 is 17. Okay, divided by, that's a 2. 2 times 4 is 8. 8 plus 1 is 9. Okay, and then we keep change, flip. Do you see anything that can cross cancel? Yes. 2 and 4 are both divisible by 2. And 4 divided by 2 is 2, and 2 divided by 2 is 1. So when you multiply across, 17 times 1 is 17, and 2 times 9 is 18. It can't reduce, and it's already proper, so you're done. Okay, for the next one, first of all, I need to change it to a improper fraction. So 8 times 1 is 8, plus 7 is 15, divided by 5 times 2 is 10, plus 2 is 12. And then we're dividing, so keep, change, flip. Remember, you only do keep, change, flip when you're dividing. If it's multiplication, you just jump straight in. These cannot cross cancel, but these are both divisible by 3. And 15 divided by 3 is 5, now easier number to deal with. And 12 divided by 3 is 4, also easier to deal with. Okay, so 5 times 5 is 25, and 8 times 4 is 32. Okay, the only factors of 25 are 5, which cannot go into 32, so they share nothing else to make it reduce any further. So 25 over 32 is my final answer. Okay, number 11. Let's go ahead and keep the denominator the same. And then 3 times 8 is 24, plus 1 is 25. Divided by, keep the denominator the same. 7 times 4 is 28. 28, 29, 30. Okay, now that I have a single fraction divided by a single fraction, let's keep, change, flip. Okay, and nothing can go into 3 and 7, but 5 can go into both of these guys. And 30 divided by 5 is 6, and 25 divided by 5 is 5. So you have 5 times 7 on top, which is 35, and 3 times 6 on the bottom, which is 18. Now you cannot keep it as 35 over 18, so I'm going to change it back to a mixed number by taking the top and dividing it by the bottom. Remember, top dog goes in the house, or in and out, in and out. That's what a hamburger is all about. Inside the house, outside the house. Okay, 18 cannot go into 3, but it goes into 35 one time. 1 times 18 is 18. When you subtract that, that's 7, that's 1. You get 17 over 18. So my final answer is 1 and 17/18. Okay, a lot involved in that problem. Okay, last one. Let's take a look. It says Jamal hiked on 2 trails. So the first trail was 5 1/3 miles long, and the second trail was 1 3/4 times as long as the first. How many miles did he hike altogether? Okay. So first of all, I'm going to have to add to find how many miles he hiked. I know I add, and I'm going to add how much he did on the first one and how much he did on the second one, right? Well, the first trail was 5 1/3. The second one, we don't actually know. The second one is not 1 3/4. It's 1 3/4 times as long as the first. So I need to take the first trail, which was 5 1/3, and multiply it by 1 3/4, because the second trail, okay, I need to find the second trail to combine those to find the total. But the second trail is equal to 1 3/4 times the first trail. So let's go ahead and change these to impropers. 3 times 5 is 15, plus 1 is 16. 4 times 1 is 4, plus 3 is 7. What number can go into both of those? 4 can. 16 divided by 4 is 4, and 4 divided by 4 is 1. So when you multiply across, 4 times 7 is 28, and 3 times 1 is 3. Okay, so 28 over 3, which is what? Well, take the top, divide it by the bottom. 3 goes into 28 9 times, and 9 times 3 is 27. When you subtract that, you have 1, so you put your remainder over what you divided by. So 28 over 3 is the same thing as 9 1/3. So that's how far he went on the second trail, and this is how long the first trail was. So let's add those together. Luckily, we already have a common denominator, so keep that the same. Add your numerators. 1 and 1 make 2, and then add your whole numbers. 5 and 9 make 14. So how many miles did he hike in all? He hiked 14 2/3 miles. If you were pausing the video as we were going along and then checking yourself and you got all those right, congratulations. You have mastered all the different operations with fractions.